This is a question on differential equation. So a radioactive substance decays so that the rate of decrease of its mass at any time is proportional to the mass present at that time. So whenever I approach this question, I want to remedially write down all these sentences in English in their mathematical equivalent. So since I quickly find out what is considered to be the mass, so since they have defined for us x is the mass in milligrams remaining at time t, so the rate of decrease of its mass is just dx dt. Okay, dx dt, x the unit is mass, right? No, x the unit is okay, what is the unit in milligrams, right? And t is in terms of what is that, days, milligram per days. So what we have is dx dt rate of decrease of its mass at any time is proportional, so I write the proportional constant k to the mass present at that time, so proportional to the mass at that time. So I have this equation, but because it is decreased, so I will just use a minus k. Actually, it doesn't matter whether you use a k or a minus k because it's just a constant. But for convention, we will just use the minus k, right, to indicate a decrease. So rate of decrease of its mass is minus kx. So denoting the x is remaining at time, write down a differential equation satisfied by x. Okay, so this is the differential equation satisfied by x, and we are supposed to show that x equals to x naught E minus kt, where x naught milligrams is the initial mass and k is a positive constant. So therefore I've chosen k to be this constant, right? And x naught is the in milligrams, so let's see, the units is the same, just have to make sure. Okay, so then we will do this differential equation by integrating, integrate this equation to get this. So let's say if we have minus 1 over kx integrate dx equals to integrate 1 dt. So this will be okay, when we integrate this, it's just minus 1 over k ln modulus x, and when we integrate this we get t plus c. You can revise on your integration techniques, right? Techniques of integration where c is an arbitrary constant. Okay, and then after that, because we can bring this k, multiply this minus k over, so we got minus kt plus minus kc equals to ln modulus of x. Since x is a mass must be greater than 0, so I do not need this modulus sign, so I will just be ln x in fact. But to do the exponential on both sides, the ln will disappear, so have x equals to e minus kt minus kc. So, and using the exponential rule, this is just e minus kc multiplied to e minus kt, and k is a constant, c is a constant, and so is exponential of e to the power of a constant is the constant. So I'll just let this constant be x naught, right? So, well, actually no, at first we cannot assume that the constant is x naught, right? So I'll just let it be a, where a is just equals to e minus kc, so e minus kt at this moment. So it is said that, okay, that is initial mass, x naught is the initial mass, that means x naught, so x naught equals to x when t equals to 0. Initial means when time is equals to 0, and x when t equals to 0 is just this thing. So we are trying to solve for what is my a, so it's a e to the power of minus k times 0. 0 times anything is 0, so I have e to the power of 0 is 1. E to the power of anything to the power of 0 is 1 anyway, so you got your a to be equals to x naught, and when you substitute back, you get this equation x equals to x naught e minus kt. That's how we get to this, and so shown. Now, another clue that we get is the mass of the substance is reduced to 4/5 of its initial value in 30 days. Take note the t in terms of day. So that means it's saying that x when t equals to 35. Oh no, x when t equals to 30 days is equals to 4/5 of its initial value, and its initial value is x naught. So therefore here we will make use of this equation to find the value of my k, because now we just need to find the value of my k. Alright, that will be when t equals to 30, so 4/5 x naught equals to x naught e minus k 30. Right, when t equals 30, the x is just 4/5 x naught, and these two would cancel off. When divide x naught on both sides, we'll have ln 4/5, alright, divided by minus 30 equals to k. Okay, and because you just divide, so then it will become, what is this value? Ln 4/5 divided by minus 30. Anyway, I'll just leave it at like this for the moment, minus 1 over 30 ln 4/5, or could be written this way as well, ln 5 over 4. Right, because minus 1 can be bring up, and it becomes the power. So the power of this is just anything to power -1 is just you just flip the denominator to the numerator and vice versa. So then we have this equation, right? Then the next thing that we are okay, so I just substitute in. So to complete it, this one, x equals to x naught e minus k, means minus 1 over 30 ln 5 over 4, right, minus t. Okay, so this is t. So then again, okay, this negative can be bring all up to it, so you can x naught e 1 over 30. What else? So this thing, right, have to be careful. This one is together, so then we have minus, then minus can bring up, so we have just ln 4 over 5. Then the t can multiply to the 30, 1 can multiply to 1 over 30 and get t over 30, and so then this thing, so this t over 30 can be bring to the power of 4, 5, and then e and ln would cancel off, so we will have 4 x naught 4/5 to the power of t over 30, and that's it for the equation. For that means x at any time is equals to this. So then if a mass of, so then we have this, we could solve this type of question. So when if the mass of, determine the mass which is present 90 days after the population. So what is this? So this is what is prepared. That means initially there's 625. So that means when x naught equals to 625, what is the mass which is when t equals to 90? Okay, so when x naught, so then I will want to determine the mass which is present. That means they want the x when t equals to 90 if x naught equals to 625. So when x naught equals to 625, x t equals to 90 equals to 625 4 over 5. 90 over 30 is just 3, and so that the answer would be 525 125. So 125 625 divided by 125 is just 5. Right, so 5 times 4 cubed, or 4 16, 16 4 64, so that is just 320. So does it make sense? So if a mass in the beginning it was 625, and this is a decreasing substance, so the mass of the substance is decreasing, so after 90 days it seems reasonable that the mass decreases to 320 milligrams. So next we have part 2, find the least then we have this answer, and in terms of milligrams, and okay, so then find the least number of days required for the substance to decay to less than 1/5 of its initial mass. So then we want x, we want to find nope, we want to find t when x equals to what? 1/5 x naught. Right, so using the equation that we have earlier, again this one that we found, which is very useful information relating t to x. So when x equals to 1/5 x naught, right, what is my t? Right, so then let's see. Right, we're trying to find this. So when x equals to 1/5 x naught, so 1/5 x naught equals to x naught 4/5 t to a power of t divided by 30. So then x naught would cancel off, so we'll have 1/5, but I want to, okay, never mind, I just write it down so that it's clearer. Then okay, we will want to, because I want to solve for t, and it will be useful if I could bring this down, so I would just put a ln on both sides. So if I put a ln here, I have to put a ln of this here. Alright, so this would be erased off, and we know that, okay, since ln is this thing, so t over 30 would be, okay, we can use the ln rules that says ln a b equals to b ln a, right, to bring this t over 30 in front. So t over 30 ln 4/5. Okay, then next we will just try to find what is my t over 30 equals to ln 1/5 divided by ln 4/5. Ln 1/5 divided by ln 4/5, and then that will become, this implies that t equals to 30 multiplied to all this. So let's see how to calculate this number. What do we get? Divided by ln 4/5, okay, multiply by 30, I'll get 216.37. okay, let's see, maybe there's some rounding issues which led to the 217. No, so remember, okay, so they are saying the least number of days, right? So if we solve for this, and we will get 216.37, right? This is the number of days to reduce to that. So at 216 day itself, it haven't reduced to 1/5 of its initial mass. So in order to reduce to less than 1/5 of its initial mass, it has to be at least greater than this number of days. So it would be 217. So that is the answer, right? And 3 2. Another way of maybe there's a, see if there's a better way of presenting this. We want to be such that the decay to less than 1/5 of its initial mass. So initially we could, let's say the mass would be less than 1/5 of the initial mass. So you use this inequality right from the start. That would be a better way of presenting this information. but when we learn, okay, when we divide by x0, take care that x0 is a positive constant, so there's no change in the direction of the inequality sign. And when we ln both sides, is an operation, because ln is a strictly increasing function, so we don't change the inequality sign as well. And when we divide by ln 4 over 5, ln 4 over 5 is a negative number. Ln any number that's less than 1 is a negative number. So when I do that, the inequality sign should change to this direction if this divided by ln of 5. So but I switch the side of these two again, so it would be this. So maybe to be clearer, okay, so it should be t over 30, right, when divided by ln 4 over 5 on this side. The sign should change to this direction, and when I switch it back from here to here, here to the left hand side, this to the right hand side, then it becomes so this should be at the greater n, okay, and this, so when I switch, this will follow the switch sign again. So then this will be, when I multiply a 30 on both sides, this will be greater than 216.37, which means it's 217 is the least number of days, right? And that's it for this tutorial.